Sharding is generally done when the size of your data is so huge that it doesn't fit on a single machine. So what we do is we split the data horizontally into two or more parts. These parts are known as shards. And then we store each part or each shard on a separate machine. Now the question arises, how to split the data? Should we split it sequentially? Like first 1 million rows goes to shard 1, next million rows goes to shard 2, and so on. The problem with sharding the data sequentially or randomly is that every query would need to be executed on all the shards. To give you an example, as you can see on the screen, we have two shards. And suppose now we want information of a user named, let's say, Alex, who is from US. Now, we don't know in which shard or on which server should we search for this user, as the data that we are looking for could be in any shard, because we split the data sequentially. So, we would need to execute the search query on all the shards. Now, you can imagine if we will execute all the queries on all the shards, the performance will be horrible. So we need to avoid this, which means that we need to create shards in such a way that for most of the queries, we don't have to hit all the shards. So what we can do is we can split the data based on a key known as a shard key or a partition key. And this key is an attribute or a combination of multiple attributes of your data. So now suppose in our example, instead of splitting the data sequentially, we can split the data based on the country of the users, which means that all the rows that belongs to the users from India will be stored in shard A, all the data that belong to the users from US will be stored in shard B, and so on. So now because we need information about a user from US, we would only execute our query on shard B, which contains the data of the users from the US. But we might run into some problems with this approach of sharding the data. Suppose you are getting a lot of traffic from the US, and because of this, shard B will be overloaded with the requests, while other shards might not get any request. So we say that shard B has become a database hotspot. So it is necessary to choose a shard key wisely, such that the requests will be almost evenly distributed. But for some reason, if it is not possible to choose a shard key which will distribute the data evenly, one simple solution is to use hashing. So you will still use a shard key, but you will pass that key through a hash function, and the result of that hash function will decide which shard the data belongs to. Again, it is important to use a good hash function, one that would guarantee close to uniform distribution. Okay? So this is sharding in a nutshell.